turn down ratio. This is mid-ranging. Mid-ranging is much, much better. What characterizes mid-ranging is that the valves are different sizes. Valve A is 10 times bigger than valve B. Now, the way it works is this. The PID control controls valve A. Another control controls valve B. The PID controls valve B. There's another controller which watches valve B. And whenever valve B opens more than 70%, it opens valve A a little bit, say 5%. Now when valve A opens up, because it's so much bigger than valve B then gets closed by the PID. So now valve B then always controls between 30 and 70%, because if valve B ever gets to close less than 30%, then the control over here says, oh look, valve B's closed a bit. What I'll do is I'll close valve A. I'll close that by 5%. And when that closes by 5%, the flow drops off so much that the PID is forced to open valve B a bit more. So that valve B is always controlling in what's called its mid-range. It's controlling from 30 to 70%. And valve A is just being occasionally bumped open 5%, or bumped closed 5%. Now, let's have a look at the numbers with two valves like this, just to make the numbers easy. I'm going to say I've got 100 litres per minute. I want to stick through that maximum. So that's the maximum I want to stick through there. And valve A can take a maximum of 90 litres per minute, and valve B can take a maximum of 9 litres per minute. So if valve A can take a maximum of 9 litres a minute, what's the minimum? So sorry, let's do valve B. Its maximum is 9. What's its minimum? Remember, the turn down ratio is still 10 to 1. .9. So, taken as a combination, the minimum flow we can put through this valve combination is 0.9 litres a minute. So that's the minimum flow, 0.9. The maximum flow we can put through this combination is 99. So when you look at that, what we've got now is we've got a turn down ratio which has improved to about, well, 100 to 1. So we've improved the turn down ratio. Each valve individually has got a turn down ratio. So individually, each valve's turn down ratio is 10 to 1. But as a combination, the turn down ratio of the entire system is 100 to 1. I can control flow from 100 litres a minute down to 1 litres a minute, which is a huge range of control. Now, another funny thing about valves is that were I to go crazy and say, hang on, what would happen if I stuck another valve on there? So here's 3 valves. So the first valve up here, that controls 90 litres per minute. That's its maximum flow. The second valve here its maximum flow is 9 litres per minute. And this little valve down there, its maximum flow is 0.9 of a litre per minute. Now a little valve like that will control just 0.9 of a litre per minute, that's only going to cost you, say, $2,000 to buy. So install, plumbing, all that, $2,000 or $3,000 all up for the whole install. Now, what this does for you, that extra $3,000, let's see what it does for you. The minimum flow through valve C, its maximum flow is 0.9 of a litre a minute. Its minimum flow will be 0.09 of a litre per minute. That's the minimum flow through the system. The maximum flow through the system is, well, it's about 99 litres per minute. In fact, it's almost 100 litres a minute. So now, these three valves have got a turn-down ratio, the three-valve combination have got a turn-down ratio of 1,000 to 1. They won't interfere with each other because of the fact that the PID, it takes a little bit of setting up to begin with. At the end of the line, what happens is the PID control outputs to the small valve. Whenever that small valve goes over 70%, a separate control, which is watching that, will open the next valve by an amount. And then whenever the next valve goes up above 70%, we open the next valve by an amount. Now there is a degree of tuning involved in this, because you can get a problem if you bump the valves, say 10% each time. What's going to happen is they are going to be feeding onto each other, they are going to be feeding back, and the whole thing's going to go into crazy oscillation. So you're going to need to find a value which is enough so that the mid-ranging works, but not so much that it oscillates. Normally it's around about 4 to 5% of a bump, depending on the size difference between the valves. So once you've found this value, the whole thing ticks over just nicely. And you end up with this system which we call mid-ranging. I've also done this system in the past where instead of using different valves, I've used, instead of a very big valve, I've used a VSD. So for coarse control, I've VSD controlled the pump. For fine control, I've controlled the valve. So mid-ranging is a great system. Of looking at it, you'll appreciate that this is a PLC program. Mid-ranging has only been around since we've been doing computer controls. Mid-ranging is a system that's been around since about 1970s. We have very high hopes that it will be soon introduced into WA. I haven't actually seen it used too much in WA yet, but you know, soon we hope it will get here. Mid-ranging is so much better than split ranging. It's slightly cheaper to install, it's much better control, much better resolution, and the turn down ratio improvement is, you know, just so much better it's not funny.